When this is the case, no transmission. Okay, no transmission will occur from the fastener to other members. Why this is important? Because this will determine why this is critical, why these rules are critical. This is critical, then you know what is the first moment of area to take. If not, you will not know. Are we clear? If not, you will not know at all, unfortunately. Okay, so now, how is the shear flow? Right, you will ask yourself, Eugene, it's so difficult to visualize. How is the shear flow related to the force resistance of the fastener? Right? Okay. So now I'm glad we have done most circle. Okay, we're going to look at an element now. Okay. Okay, and I'm going to copy this cross section. Okay. So we are aware that this is our transformation x1. And over here, this is our y, z, rotation about x. Okay. If we were to put an element, okay, we will put an element down here. Okay. So if the element down there, this is where our element is. Okay. So when I draw that, this is our element. Right? You can see where our element is. Okay. So that is our element. Okay. And then we have at the element, we have a hole. Right? We have a one. Let me see. Do I have our orientation right? Yep. We have our hole down here. Okay. So we know that the shear flow will come down this way, or the Q will come down this way, right? Wrong color. After it comes this way, then it will transmit. Right? That's our transmission direction. So the transmission direction is across here. Can you see that? So that is our transmit, yes or no? So this arrow over here is our transmission. Okay. So the transmission is relative to the hole, right? It is pushing, or is pushing this element, or sliding on the hole of the element. Okay. Now, if now we were to draw the fastener, okay, we were to draw the fastener. So now this is our fastener. Right? So the fastener, if you look at this arrow, it is sliding it's sliding at the direction relative to the fastener. right? It's sliding to the direction relative to the fastener. So this sliding direction is parallel to the what? To the parallel to the surface of the nail. Right? When it's parallel to the surface of the nail, anything that the stresses or forces applied parallel is known as what? Shearing stress. Yes or no? So the shearing stress over here is fastener or shearing force or shear force resistance of the what? Fastener. Okay, of the fastener. So the only way to get this value, okay, which I will call this, usually they call it F. Okay, the only way to get this value is what? By what? Experiment. Okay, so how do you do this? Okay, so what you tend to do is you will buy nails with either different length or different diameter. You nail it into your wood. Okay, you put a spring gauge at one end, and then you pull until the nail become loose. That is the what? Force resistance. There's no way to calculate this, okay? Because it's a function of it. I mean, there is an empirical relationship. So what you do is you buy different nails with different length and different diameter, and then you pull. Okay, you pull them out. Only after you pull them out, you from your spring gauge, you can see, okay, this requires 80 Newton, this requires 20 Newtons, and so on and so forth. Okay, so this is how the shear flow is related to the force resistance of the nail. Okay, and you have to visualize this. So the thing about this concept over here, the two most important rules are here. Okay, rule number one. Okay, rule number one. The shear flow must distribute throughout the entire member. Rule number two, only after the shear flow is distributed to the entire member, the fastener will then transmit the shear flow. Okay, so this arrow that we see down here, right? This arrow that you have down here, right, is the what? Transmit of the shear flow. Okay, so based on this concept, we're going to do our first problem. Okay, so the problem, and I think this is one of the, it's not difficult, but it has a lot of factors. Okay, and we are dealing. I want you to start dealing with problems that have multi point of failure. Okay, and let me elaborate. Okay, so this is the same diagram. Okay, so this question uses the same diagram. Okay, the double wet griddle is constructed from two plywood sheet that are secured to wood member at its top and the bottom. So if you look over here, so these are the sheets. Okay. So this is also the wood sheet. And then at the top are the wood member. So this is also the wood member. Okay. Now it gives a lot of factors over here. The allowable bending stress for the wood is 8 KSI. And the allowable shearing stress is 3 KSI. Okay. If the fastener are spaced in 6 inches, and each fastener can support 600 pounds in a single shear configuration, right? Then determine the maximum load P that can be applied to the beam. Okay. So let's slowly, as I said, this question has a lot of layers. Okay. And how all these layers, okay, are telling us how the structure is feeling. So let's look at this. Given the allowable bending stress, okay, is equal to 8 times 10 to the power 3 psi. For this case, the formula that we're going to apply is stress is equal to P over A plus minus my over I. As you can see over here, there's no axial load. This is equal to 0. Okay, so this is equal to 0. So what we have, the first failure mode is, one of the failure mode is my over I. Okay, we can see that it's very clear cut over here. Then the next one given to us is the shear stress allowable, which is equal to 3 times 10 to the power 3 psi. And we know the shear stress is equal to Vq over IT, right? Okay, so this V, right, the shear flow or the shear, not shear flow, tongue twister over here. The shear force will induce the shearing stress, okay, V, right? And then the third one, which represented by Q, which is equal to force resistance of the what? Or did I call for, or fastener resistance force? And then divide by spacing. And this is also equal to our VQ over I. Okay. And we know, okay, what we know, P, right, is dependent on M and V. Okay, so what this P is, okay, we have to find is dependent on both the moment and also due to the what? To the shear force. So you can see different mode of failure. So the mode of failure over here is normal stress. Then we have shearing stress. Then you have failure due to the what? Due to the fastener. Okay. Then you can see the shearing stress due to the fastener. Okay. So what I want to do first, the normal stress is straightforward. The shearing stress is straightforward. I've done enough with you guys. Next, we are going to look at the due to the fastener. Okay. Now, what for the fastener? Let's look at the fastener. Given to us the fastener resistance force. So let's consider failure due to the fastener. Okay. So given to us, okay. given to us the fastener resistance force